mic is on. Sound seems to be on. Okay, so today, Bryce and Nate, what do you guys think we're going to learn today? Math. What do you think the screen has to do with what we're doing today? Exponential growth. What are some images you see up there? Charts. What are the charts showing? What kind of things in real life would increase? Money. Money like when? Why would money increase? Interest. If you put your money in the banks don't give you a whole lot of interest, but they'll give you a teeny tiny bit every month, right? What else? What were you going to say? Profit, yeah. So if you're a successful business, you're making profit, yeah. Investments, your stock would go up, yeah. Population, right? What about I think this is trying to show a really old classic car, the value of it would increase over time, right? So we're going to be dealing with all those kinds of things. Yeah, absolutely. All right, we're also going to look at decay. Have you guys heard the word decay used in science? Decay, like when? Half-life? Yeah. And we could talk about sales going down or the price of something, like when you buy a brand new car, not a classic car. The price of a brand new car, as soon as you drive it off that lot, it's not worth the $30,000 that you paid for it, right? Because it's used. All right. So before we get into exponential growth and exponential decay, which is a tiny bit more complicated than some of the simpler stuff, I want you guys to practice with calculating a markup. What does a markup mean? Yeah, it's like they're going to charge more for it. So I'll do the first one, and then I want you guys to try the next two. So the wholesale price, the price that the company is going to charge to a store to sell it, is listed. The markup is also given. So I'll do this one, I think. I'm going to do the middle one, the sunscreen. So let's say the sunscreen costs $3. That's cheap, but it's the wholesale price, right? So that means that the people who make the sunscreen charge Walmart $3. So Walmart pays $3, and then Walmart marks up the price. Yeah, that's what markup means. So how would we figure out how much Walmart's going to charge if they mark it up 8%? Okay, I'm hearing everyone saying we're going to take 3 and we're going to multiply it times 8%, which 8%, remember, percent's out of 100. So that means you take your decimal, which is after the 8, and move it twice, which is why it's 0.08. Okay, that's a good start. What's that going to be if you multiply? I'm going to have a calculator. Okay. So this is 24 cents. So that's not the right, that doesn't make sense, right? We're saying they're increasing the price and they're only going to charge 24 cents. They're going to add that. Okay, so we're going to take the $3 and we're going to add 24 cents to it. So they're going to charge $3.24, which doesn't seem very realistic, right? They're probably going to charge more than that. Okay, would you guys be okay if we wrote this a slightly different way? I'm going to show you one more way. Isn't this the same thing as saying $3 times 100%? What's 100% of 3? Just 3. It's just like 3 times 1. So we're charging that, that much plus 8% more. Right? Does that make sense? We're going to charge $3 plus 8% more of it. It's the same. You might not like it, but it's the same. Could I write this as 1.0 plus 0.08? That's just the 3, because if I distribute it, that's 1, 3. 3 plus 8 cents times 3. Which, couldn't I write this as 3 times 1.08? So here you had to do 2 steps. In the blue work, we did 2 steps, which is fine, and we got our answer. But if you want, you could save yourself some time and just say, I'm going to do 100% and 8% together. And you do it in 1 step. So on your calculator, if you do 3 times 1.08, you're going to get the same answer of 324. It's just doing it all in 1 step instead of 2 steps. Is that okay? Okay. I'm going to give you guys 3 minutes to figure out the markup for this pair of jeans and the markup for this really expensive pair of sunglasses. Okay, let's come back together. And for the $40 increase, we could write this as $40 times 100% of that plus the 60% markup, which would be the same thing as 40 times 1.6, which is $64. How'd we do? Good? Okay. Over here, was the decimal a little bit trickier? No? So this would be 100% plus the 2.5%, which we could write as 1.025. Did you guys write it correctly? So I got 101 and 40. I'm going to round it to 48 cents because it was 475, and the 5 will bump the 7 up to an 8. Can I explain which part? Okay, 1, 2. That's why. That's our decimal. All right. Why do we always include a 1 or a 100%? Where is that coming from? It's the original price. If we didn't include this, all we would be calculating is how much we're increasing by. That would be like getting the 24 cents. So like if I didn't include the 100%, our answer would be how much we're increasing it by. But we have to do that plus our original. So the 100% is including the original price. Okay, let's try a decay problem. We won't do all 3 of these. But let's say that these are on sale. These are sale items. And so a discount, which item do you guys want to calculate the discount of? Okay, do the one you want, and we'll write all 3 of them up. Pick one. Just do one. Okay, so I realized I kind of didn't really explain it. So if you were to do a discount, we would subtract. So we're not going to pay 100% of 75. Right? 100% would be full price. We're going to pay 25% less, right? So if we're paying not 100%, what percent are we actually paying? We're paying 75%. Which we could write as 75 times 0.75. So that would be $56.25. We're subtracting. That's the difference. Growth, we're adding. Discount, we're subtracting. So could you guys do the Sharpie or the highlighters? This would be, instead of 100%, we're only paying 95% of it. So I'm curious what decimal you guys would put here. 0.95. This one is 95 because we're subtracting 5%. $7.60. These are kind of expensive highlighters. I think that's pretty accurate. All right. How are we feeling? Not very confident? Okay. So I want to check and see if you guys are understanding what we're doing. So we're going to do a matching activity super quick. We're going to take about 2 minutes. You want to see the answer to the last one? Okay. The shoes, we have $100 and a discount of 0.5%. So you're going to be paying 99.5%. So move the decimal twice, times 100. I can do that one in my head. 99.50. You say 50 cents. This is not 50%, this is 0.5%. This would be 50%. Alright, so here are 3 scenarios. We have a sales price of something. Something's on sale. We have tax being added to something. And we have something that's half price. So 3 different things. They're all, whatever, I don't know what we're buying, but it's worth $18. Okay? So, something's worth $18, and each of these represent how much you're going to actually pay. So I'm going to give you about 2 minutes to see if you can match them. Let's come back together. So we were answering this question. If we had a tax of 9% on something that cost $33, I'm going to tell you that this one is not the right one. Who can explain to me why that one, what does that one represent? This would be a discount of how much? Of 9%, because that would say 100% minus 9% is where we got that 91%. Okay, now we're looking for the, I wanted the total. So this one's not right either. What does that one represent?
Well, that's just the tax.
That's just the tax. So it's not like wrong, it's embedded in our right answer, right? We need to figure out that. That tells us how much the tax is, but this tells us our total because we have to pay $33 plus how much is our tax? Well, our tax is 9% of 33. What is 9% of 33? Did anyone figure it out? This is, no it's not. It's 2.97 plus the 33. Yeah, oops. We get the difference between growth and decay? Yeah? Okay. I got to break it to you. This is 7th grade math. We haven't even stepped into high school math yet. Are you guys ready now?
No.
No. Where's the can-do attitude? All right. We're super close. All right. This is stepping it up. We need to come up with a formula. This is almost our formula where we have the original price, right, or the original amount, times 100% plus the rate, right? Or, so this would be a growth, and decay, or a decrease, would be the original times 100% minus whatever our rate is, right? Nope. All right. So, okay. So these two formulas represent a one-time increase or a one-time decrease. But when you talk about like half-life in science, isn't something constantly decaying, right? Or if you talk about when you get interest in your bank account, it's not just one time, it's every month, right? So there's a little bit more to this. How do we come up with if we constantly do it, right? If we constantly are getting interest. What if you get interest 12 times a year? Do you guys want to constantly do multiply, like lots of math? There's a shortcut, you know?
My question was like, for our word problems,
Mm-hmm.
will always be from like the original amount,
Yeah.
or is that constant?
We're going to get there, but not today. All right, so here's a simplified version of what we're going to look at homework tonight. So let's say, I just made up this problem last night. The math department, let's just say, has 100 TI graphing calculators. We use them a lot in AP Stats. So let's say we have 100 of them for students to use. But we want to get more because we're expecting more students in AP Stats. So let's say that in our budget, we can purchase 10% more calculators every year, right? So it's not just a one-time done. It's 10%, 10%, 10%, 10%, 10%, 10%. Can you guys help me? So we would have 100 calculators, and then we're going to have a 10% increase, right? You can just hang on to it like have a seat. Thank you. Sorry. 100%. And then this is 1 year, we've increased by 10%. Yeah? So we have, that's our first year increase. But then they're going to add 10% more calculators after that, right? So how much is this? Let's see. That would be 10% more. That would be 110 calculators, right? Yeah. After 1 year. Okay, then we take this. Now we have 110 calculators. Oh, it's the end of another year. We're going to add 10% more calculators, which is going to come out to be, I should be able to do this in my head, but 121 calculators. Okay, so that's another year. Now we have 121 calculators. We're going to do 10% more of that. Right?
Wait.
That's going to be 133.1.
Wait, how would you write that as like 110% is at 1.1?
What's the pattern, right? Let's look. What was our original amount? Where do we find that? This is our original amount. And then all we're doing over and over, we did 1, 2, 3 of the same thing, right? So what we really do, our formula, is we have our original times, we had 100 plus 10%. 100 and 10%, right? How many of these do we do? However many years we're going to buy calculators. So it's our original times our 100% plus our rate. Here's the grand finale. We don't multiply it times 12 for 12 years because that would be addition. We're multiplying. And how do we represent repeated multiplication? Exponent. T times. So I'm going to multiply this time, times this time, times this time. So that's our big formula. Okay, so it looks like this. We've got our original amount, and then we're going to add or subtract our rate, or T represents time. It could be years, it could be months. Okay, it's a T. Got it? All right. So I don't think we need to talk about this. We already talked about it, right? One of them is going to be an increase, and it would look like that. One of them is going to be a decrease. That looks like that. Okay. All right. So I want to see if you guys can. I don't think I want to get to this yet. All right. It is a Mike Trout autograph. So this is on a notes page that I need to hand out, but it says Tony purchased a signed baseball in the year 2000, which I don't know why it would be. Okay, maybe he was a minor leaguer in 2000. How old was Mike Trout then? Not very old. For $3. Experts estimate that the value of the baseball will increase by 10% each year. The value of an item over years can be modeled by the equation given. So it's asking, can you guys set up an equation? We know that we have $3, 10% per year, right? So our equation, they're asking for f of t equals, I'm just writing this larger because it's hard to see, our original times our 100% plus our rate to the t. So you guys think of what that would look like. We're going to write down here. So I gave you guys the wrong worksheet, did I? No, I didn't. Yes, please. I collected it. I'm going to grab it from you guys because a whole bunch of you walked in. All right. So you guys have it in front of you. We're going to ignore the back side of this worksheet. We're on part 2. And part A says write the function. No, this is not homework. All right, these are your notes. So here's our function. Oh, it wants baseball B of t. Okay, it wants to call it B. So we'll call it B. B of t equals, you guys got it? What's our A, Eder? What does A stand for? Original amount. So grab your paper, and underneath it, if you need to, draw an arrow to A and say, oh, remember, A represents our, I don't know why I put it there, original. Or starting, or initial, all those fancy words. Okay? So our original cost of the baseball is $3. Okay. All right. And then we're going to pay 100% of that, plus our increase. Because it's an increase, we have a plus sign. It's an increase of 10%. Do we know how many years we have this baseball for? It doesn't tell us yet. I think later in the problem it asks, but it doesn't tell us yet. So we're just going to put T. Right now, all we're doing is writing a formula. There's our formula. We don't usually like to write with percents just because they just look messy. So that would be, this would be 1 and 0.10, 1.1 or 1.10 to the T. All right, we're going to skip B, C, and D for right now. Can you guys go down and read the next bold part? It says Tony bought something else, I think. She bought a signed baseball card. And can you guys do letter E? Write the equation for that. So, looking at the second part of the problem, it says Tony also bought a baseball card for $1.25, and it's estimated, the experts say, that it's going to increase in value by 20% every year. So it must be a pretty good baseball player. So, C of T. They asked us to use C this time. C of T equals our initial value. This one was worth $1.25. It's being increased by 20%, so we can write that as 100% and 20%, which would look like 1.2. You don't have to put the 0 at the end, even though I did. Good? Okay. This is 100% plus 20%. Yep. Okay. The rest of the problem is asking us to estimate something. So I need you guys to put your pencils down, and I need your attention back up front for a minute. All right. We don't have time to get on Desmos ourselves, and so that'll probably be part of your homework tomorrow. I'm not going to have you do it right now, tonight. But you're going to be graphing your function. So the things we just wrote down, you can type them in Desmos super easy, and it's going to be an exponential function, right? So then I could ask you to predict things. So let's just use this graph, and Bryce is going to be our lucky volunteer for the first one. All right, Bryce, here is our function. Is it a growth or a decay? A growth. And so it says we have years down here and the price over here. So what is the worth, what is the value in 30 years' time? How would we do that?
40.
Your answer is 40? It started being worth 10 at 0 years. So then in 30 years, here's 30, how much is it going to worth? Yep, that's a good estimation. Okay, in 30 years' time, the graph tells us it's going to be worth about 43. How else could we have done that? Couldn't we have taken our equation? Let's see if Bryce is accurate. In 30 years' time, 10 times 1.05 to the 30. Everyone grab a calculator. Okay, do 1.05. Let me finish and then I'll answer. 1.05 to the 30th power. So I need you to try this. 1.05 to the 30th power times 10. How accurate was Bryce?
Pretty accurate.
What was it?
43.21.
Nice, Bryce. Cool. Yeah.
Obviously it works out.
Yeah.
But why is time
Because it's this year we're increasing, and the next year we're increasing, and then the next year we're increasing. So we're multiplying a bunch of times. All right, here's the second question. It's slightly different. When will this stock be worth $70? I've switched it around now. Okay, so I need Chris to help me. Chris is my lucky volunteer this time. When is our graph at $70? So which axis are we looking at now? $70, we're looking at the dollar axis. Where is it 70? So follow it over right here, which is 40 years. So we're saying at 40 years, it'll be worth $70. Good question. How would we do that in the equation? We wouldn't substitute 70 in for t, right? 40 is our year. So we're saying that 40 equals our equation, and we're looking for t. Right? Could we solve for t? We would divide both sides by 10 first. That gives us 4 equals 1.05 to the t. Do we know this exponent? No. 1.5 times what times what times what gives us 4? We don't. We have not learned a good way to do this yet. That's when we need logs. We're not there yet. So the only way you guys are going to know how to do it is off of a graph. So that's why part of tomorrow night's homework is you're going to have to graph it and just estimate your answer off of the graph. Yeah. You're going to use the log, which is it undoes exponents. Log is the inverse of an exponent. Yeah. Okay, so let me tell you what your homework's going to be. All we've done so far is write equations, right? You're not going to actually find answers tonight. So even though the problems ask, like when will something happen, you're not going to answer that part. Your only job in homework tonight is to set up the equation. So let me pass out the homework. I need to show you which 6 you have to do. It's only 6 problems, okay? You guys can clean up your mark.